Hello, welcome, and welcome to the first meetup of Flutter Portugal this year. Thank you. Cameras are always like this. We are doing just a small sound check. Let's just say welcome to this event. You online don't know how many people are here, but I see more than two. More than two, less than 100. So you're missing out. You should have been here. The event is going to be amazing, and we are going to, after, we'll have some nice surprises for you all and maybe some other stuff, so stick around. The bad thing of being present is that I'm going to be watching you and I'll be in the door, so no one cannot leave. So the event is around 6 hours. I hope you like it, but then it's going to be all right. The sound is good online. Just sound check. Yeah, okay. Now the good stuff. So my name is Philippe. I'm one of the organizers of Flutter Portugal. Okay, Flutter Portugal community. This community, it's always thinking about giving back. Okay. I need to cut the music. Okay, all good. Now there's no music behind it. Okay. So the objective of the Flutter Portugal community is really give back. Okay. And we gave back in many ways. We partnered with some entities. The most well-known is Vost PT, that they have, for example, under their broad umbrella, the Focus PT application, known in Lisbon, known in Portugal, sorry. And we tried also to have projects for people to hands-on work, content online, Portuguese or workshops. You need it, we have it. Anything to help you learn and improve your tech skills in Flutter, okay? So why do we exist? Yeah, talk about Flutter, what else? Sharing knowledge and news and support each other, okay? That's the most important part here. Do you think you're part of the community? Well, are you curious about the tech? Do you want to learn more? Do you wish to improve your tech stack? So join us. And more, 3 principles, and this is really important for the community: motivation, respect, and reliability. What do I mean with reliability is have constant events happening, constant content and content always coming out and having out there. So we have different roles, but that doesn't matter here. But this might be one of the most important slides here. The events will be always free for the attendees. If we create any content, every content will be open source and will be always community first, okay? Always community first, always you guys, you girls that are first here. And then, of course, what you expect: TED Talks, workshops, social projects. Simple. So just to recap really quickly, we had the definition of success in 2019, and we were able to have 12 events. We reached 100 people, 500 people in Meetup, and we had 3 local organizers. We did 17 events before our fatidic, you know what, not Voldemort. And nowadays we are 500 in Meetup. We are around 6 organizers. And in the Discord, we have 480 people online. So join the chat. The link is there. Join the community, talk with us, and we'll see more about you. Meetup. This is just to give you a round sensation. Most of people are curious. So the experience out there, people who have contributed to Flutter, they are there to answer questions, but you might also have a difficult question to ask, but for sure someone online will be able to answer you. Proficiency, quality of the events. This is, let's say, excellent kinds of events, but now it's your time. It's your time for attending this event. Let's start with a small introduction by Rose themselves. They are our hosts. It's important to hear from them, and then we'll start the talks, okay? So without any further ado, I pass the word to Christiana. Let me just, jump in. Please.
Hi all. I'm Christiana and I'm the engineering manager of the apps team here at Rose. So first, let me thank you all for being here in person and online in this first edition of the Flutter Talks event at Rose in partnership with the Portugal Flutter community. So, let's introduce our agenda. So, today I want to tell that we have an amazing panel of speakers. The first one will be Mireia. She will give us a brief introduction about Rose. And then in the second part, we will have two tech talks. The first one will be given by our engineer, Renan Araújo, and he will talk about his experience developing a desktop app and the challenge that he faced so far. In the third part, we will have another tech talk that will be given by Erick Zanardo, a software engineer from Very Good Ventures, and he will talk about the power of Flutter to create games. In both of these sessions, we will have a Q&A time where you can interact with both speakers and ask all the questions that you may have. Okay. So without further delay, let me introduce you to Mireia for a quick introduction about Rose.
Hi, everybody. Thank you, Christiana, for the intro. Thank you, everybody, for being here today. I promise I will be fast doing this introduction. I know that everybody's excited and is looking forward the two rock star speakers that we have after me. But I think that introduction it's interesting first, as he was saying, we are the host for the event, but also because it will set the framework or the use case that actually later and will frame the problem or the use case that we are going to be solving through Flutter. And Renan is going to present how we build the desktop app and what the challenges were encountered through that process. So to do that, it is said that one image is it's worth 1,000 words. But in this case, we have a cool video with cool music that I'm going to play. Okay, so it's always better to start with music as introduction. So as you see, we are a spreadsheet, and as you know, spreadsheet has been around for many years now and used by many people. Actually, we estimate that more than 1 billion people use a spreadsheet every day worldwide. What we want to do is to do a spreadsheet, but faster, better looking, so more beautiful, and also add a bunch of features that enable or help us in our vision of making computation available for everybody. What we want to do is to enable our users and to empower our users to access data connectivity, automation, and web creation through the spreadsheet. And we want to do that also in all the platforms and making this available on any device. And that's why also Flutter comes into the picture for this, right? So as I was saying, we are in a spreadsheet, so everything that you can do on a spreadsheet can be done at Rose, but we have super cool add-ons on that, one being of integration like sharing and community that I'm going to share now in a few seconds. So first, integration. So we allowed, and this is super powerful, to integrate business data from tools and public databases, but also import and export from APIs. And we also add the features, for example, Data Explorer, to tackle this data and to use this data as the user wants. For example, in the video that we saw just a moment before, you saw the integration with Google Analytics, right? So in 2 clicks, you can integrate your Google Analytics report, have this data available. In 2 more clicks, you can create beautiful tables and share it to the wall. Now, if you want to make this report even better, you can integrate with your social databases available, for example, Twitter, and you can incorporate there your Twitter, your likes, your views, etc., to that report. So it's even better with that thing. And it's 2 more clicks on that. You want to have your information updated without doing anything else. You can also use function and create functions to pull this data automatically with the frequency that you want. So integration is really powerful in our platform. Now, for this kind of elements, there is always 2 main roles, and people can play this role anytime at any time, which is the creator or the editor, and then the consumer of the content. In the example that we have here, let's imagine that, for example, I'm from a lead generation team, and I'm making the pool of leads that then you account managers will consume later. So with this tool, we can create this with integrations that we have, make this report, but then I can make this live and share it with all of you, and all of you can interact with this report without breaking the original report that I was building, which is a common problem that it's with the spreadsheet, right? It's more or less one-on-one consumer, but here is one-to-many that can consume, can interact freely. For example, in that case, you could interact by changing the number of employees, location, investor. You can do all of these changes by separately without interfering with each other and with an individual view with that. So this is also super powerful. And to put a personal example of this is not only with this kind of report, but I also have a tool that I create for the all hands for the company, in which I send to have questions in advance from the team for the all hands if they want to present them before the session. So I send that in a shape of a form, so anybody can introduce their question there, and then I can see it in a table. The table gets updated as if it were in a database, and it's super cool. And also with another integration, which is on Slack, I'm able to automate the heads up for the team. So every month before the all hands, everybody gets the heads up with the link, and they can go there with the tool, with the form, and introduce the question. So it's super cool for me. And of course, community. We don't want to do this journey alone. We want to do that with our users and to build our community with our users. It's for that reason that any creator, any editor can create their spreadsheet, their tools, and then share it and publish it to the wall. So anybody can use it. And for example, if I taking again the example of the Google Analytics, I'm a growth manager, a senior growth manager. I have my reports and are super, and I love them. My teams love them, are super useful. And then there is another user that is new to the world to growth, but wants to start doing that. They don't need to face this blank page fear. They can start with something. If that senior, like a user from the community, shares that with the world. So this is published. They can access, and in a couple of clicks, they can start using it without this white page. And that it's, I promised that I was gonna be quick, and this is it from me. Now I pass it to Christiana.
So now we have a web version. We started some years ago, we started with a web version. And right now, since the beginning of last year, we started development of a desktop app. We already have a support for macOS and Windows, but we don't want to stop right here. We want to build a cross-platform solution that can better fit our user needs. So, to talk about this matter, I want to ask to Renan to be here in the stage for his talk. He will give us a brief introduction about what he has been doing at Rose and what has been his experience during these developments. So, welcome, Renan.
Thank you, Cristiano. I'm just gonna stop a little bit sharing the screen, okay? Because I'm gonna change this to not mirror everything. Okay. Funny when things are up live. Stop sharing. not mirror, because I need to see my annotations. Good. And now back to StreamYard, share screen, secondary screen, and we're good to go, I guess. Is everything okay on the screen? Amazing. Yeah, so it's great that we had this introduction more in the aspect of what's roles from the standpoint of a product, because I always have to do this in my talks. So just going to skip that and go for the technical standpoint. And the goal for today is to talk a little bit about the experience of creating the Flutter desktop app for Bros from scratch, and what was all the decision-making process to reach the point that we are right now. So, okay. First of all, presentation, that's me. Renan Araújo. I work at Bros, and also I'm part of a collective called Bluefire that maintains some open source Flutter projects, such as Flame, which is the topic of the next talk just after mine. That's Eric, that's also part of Bluefire, will be sharing with you today. So yes, I'm also part of Bluefire, and yeah, live here in Porto, and I work in this very company here, Bros. So yeah, you can see some of my socials and stuff like that, and some useful links like GitHub and stuff like that on my website. And yeah, so for today, we're gonna go through these topics. Why we chose Flutter? Is Flutter desktop all that amazing? And some problems, some challenges we may face it on that as well. And but before all of that, a little bit of context. Rows, consider this in a technical standpoint. Rows is a spreadsheet with superpowers. Still superpowers, but it's still a spreadsheet. And spreadsheets are complex in now different points of views. For example, from the point of view of a user interface developer, which is the job of most Flutter developers, it's really complex. For example, in this case here, of rows, we have the possibility of having multiple tables per page. So you can have tables with millions of cells sharing the same scrolling context, vertically speaking. And also, each table gets bigger with the selection of the user or content changes. So the table, we call it as elastic, because it's always wrapping the content and assuming the most compact size as possible without hiding content or user selections. So if the user selects a lot of cells that's beyond the current size of the table will expand. So that will have impact in the scrolling context for both vertical and horizontal axis. Yeah, this is just an example. I'm getting a little bit ahead of myself, but it's the point here. It's a very complex product. And also, at the time we started the app, we already had the web app in production, launched V1, ready for the user. So it starts the native app from scratch. That what we did, and not reusing the existing web app was a big decision that we had to make at that time, because we could just wrap everything on Electron. And this brings us to the first point, which is why we chose Flutter in the first time, because choosing Flutter means that we had to rewrite everything from scratch, even though we already had a pretty complex spreadsheet web app there. Okay, so the question is, why we chose Flutter? The answer is because Flutter is great. We have a break now, and then the next talk. So any questions? Oh, you want the long answer? You really want that? Okay. Long answer starts with this. This is a spreadsheet. Okay, it's a test one. All cells are pretty much the same, so it's not one of the most complex ones, even not one of the most complex ones. And this is on a 4K screen. This screen you're seeing right now, this TV is a 4K screen, so it's
pretty well scaled there. If you are seeing from YouTube, good luck trying to read whatever is in itself. So this is a sample of where we have a very demanding user interface in terms of performance. So this comes for our first requirement, which is performance. And this is the biggest one, and it's a deal breaker for us. We are going desktop, and when we decided to go desktop, it was not to rival against other spreadsheets running on the browser. It was against other spreadsheets that all of them are mostly built in native or native-like technologies. And the user interface in most of them, especially the green one, I'm not going to say the name of the competitors, but the green one has a great user experience. You can do selections and all of that, and you don't see hiccups in performance at all. And we wanted that. And we have something on desktop that's called pixel scrolling, where you scroll and each pixel of that scroll matters. But if you go to spreadsheets in the browser, most of them do not scroll with pixel scrolling. They go header by header, column by column, row by row. So this is something we also wanted. So yeah, we also wanted to go multi-platform because for obvious reasons, we are a startup. We don't have huge resources to split into each new platform we try to achieve. We would go to rewrite everything from scratch. We don't have time, nor people, nor money to do all of that. So yeah, we want to do multi-platform. And the last requirement, these are just, we of course had smaller requirements, but these three ones are the biggest ones that were deal breaker for us. But the last one is more related to, thank you, to, oh, you can leave it on. I think it's better for this. Okay. Thank you. And yeah, this one is more technical because we engineers we also have feelings, and we don't want to have a bad quality of life working on this. So we wanted more modern tools. And this is preferable, a flexible declarative UI, because the web app was built on React.js, and it's pretty great. Building UIs with declarative UI is a path that you cannot go back. Once you start doing that, once you learn doing that, you stop thinking about building UIs in a different way. So if you know Swift UI, Flutter, Compose, or React, you probably know what I'm talking about. So yeah. As a summary, these are the three things that made us decide what would be the technology that we would choose. And yes, the 4 candidates that we had for this app were these ones. Of course, we had some other candidates before that, but we wanted something open source and something reliable. So these were only the 4 serious candidates. And okay, the first one is Chrome Embedded Framework, which is, I call it the weird choice because it's kind of like Electron, but it's more like when you give access to Chrome to C++ developers. And basically, out of the Chromium framework, everything's native. And there's a bridge, a C++ bridge between the native part and the framework. And still, the UI is still HTML, JavaScript, and CSS. And the interesting part of this one is we have big cases. Steam is built on CEF. The earlier version, I don't know if the latest version of Spotify is still CEF, but the earlier version were. And of course, OBS Studio also. And numerous other big players there are made with CEF. The other one is fully native, which is basically using native technologies, but the thing that called our attention at that time was SwiftUI, because at that time our main targets were macOS. Of course, we wanted to go to other platforms in the future, but macOS was our main target. So SwiftUI with that declarative API was also a serious contender. And the biggest candidate, apart of Flutter, was Electron, because we had already the web app. We just need to put that in an Electron shell, publish, and we are done. We don't need to spend a whole year building everything from scratch. And I call it the easy choice. So yeah, let's go again. Okay, of course, at last Flutter, because yeah, obvious we chose this one, but okay, I'm gonna explain why we chose it. Okay, the first requirement, I guess I'm going from last to first, is the modern tooling and flexible API. Okay, about modern tooling, CF, it's not about that. CF is completely stuck some decades ago, and of course, like everything around the C++ ecosystem, if you need some modern SDK or something like that, we would have a lot of work that we were not focused on. We were focused on building the spreadsheet, not, for example, if you need Google Analytics or something like that, to bind the C++ with a native thing. So we didn't want to do all of that because our UI constraints are complex enough. And also, SwiftUI is amazing, but it's limited. We can't build something like the grid, something like the spreadsheet engine on SwiftUI purely. We would have to go to AppKit. And also, the next problem is multi-platform. This is kind of obvious for native. And the biggest of all that killed all of the other containers, handle performance using the DOM to render the grid was a problem. We wanted pixel scrolling, and yeah, we can spend the whole day saying Flutter was a great choice, but truly it's the only one considering our deal breakers. So handling performance is amazing. It's multi-platform and modern tooling and declarative UI. So that's why we chose Flutter. Okay, but is Flutter desktop all that great? Keep that question in mind. The intrinsic advantage of using Flutter comes with using Flutter desktop. So Dart, amazing. Hot reload and restart, amazing. Tooling and dev tools are always still there, and all of them works really great, both on Windows and macOS, especially the dev tools that you measure the profiling of frames per second, and you try to find janky frames and stuff like that. And also the ecosystem of packages. Of course, not all packages working on desktop, especially some plugins, but it's still pretty great. You still have the Flutter only packages, and also some plugins like charge preferences already works with any problems. And yeah, so the ecosystem of packages also comes with that. So, okay, this question, is Flutter desktop really all that good? You can answer that from 2 points of views. Flutter desktop compared to other desktop solutions, and Flutter desktop compared to Flutter mobile. So most people that work with Flutter right now work with Flutter mobile. So change that for Flutter desktop. How will be that experience for you? The answer is different from the answer if you compare Flutter desktop to other choices. And that may be useful, and I'm going to focus on that from now on. And okay, is that all that good? Spoiler alert, it's not perfect, but it's still amazing. It's still a great life working with Flutter desktop. So yeah, Flutter is proven in the mobile world. There's lots of cases out there, and if you are like me, once you run Flutter Run, it's a path that you cannot go back. I remember in Christmas 2018, I was with my family and I was talking about Flutter in a Christmas reunion. Yeah, that was really fun. Anyway, okay, so when you start to work with Flutter Mobile, you don't need to build everything that's on the screen. You already have Material, Oracle Pertino, and Material is amazing. It's complex. It's complete There's lots of stuff there. So working with Flutter Mobile is really great with a lot of help from these two things, right? Okay, but how about desktop? Yeah, this meme here, the whole the inherit is everything, everything. It's good, but there are some challenges. Okay, we're gonna go through them a little bit. So Flutter desktop challenges. First challenge, viewport is big. Obviously, you are on the desktop and there's nothing stopping, unless you do some tweaks, there's nothing stopping the user from putting your app in the entire screen, and also there's nothing preventing the user to go to Amazon and buy a 4K monitor and run your app there, and the user always expects your app to run great. And it's not only about performance, but also how you think your user interface. For example, this one on Flutter Gallery is a great example of a shift between a small screen to a big screen. So, for example, we have this little e-commerce, and it adapts itself to a bigger screen. And it not only changes the disposition where you see things, but changes also the navigation of the user. For example, mobile, when you open the cart in this little simple app, it's a new route, and it pops up in the entire screen and covers the entire screen of the user. So if the users go back, the user is directed to the initial screen, okay? But on desktop, that's a side panel. It's not a new route, essentially. And we can have lots of these things on desktop, where on mobile, that would be an entirely new screen, and on desktop is just a part of the screen, it's a sidebar or a side panel or something like that. So this is something to think about. And it's all about the philosophy of how you build things for multiple platforms. If it's the case for you, that you're going to support something that's probably mobile and desktop, this is something to think about. And I took inspiration from Flutter. Before working with Flutter, I worked with some other cross-platform mobile frameworks or tools or anything they call. And yeah, the thing I could see that most of these tools, they support the common ground between platforms. And if you want to go something that's specific to Android, you would have to probably go to a third party or just to build yourself. And yeah, that's not what we see in most cases for Flutter. For Flutter, you can support stylus, you can support the inverse tip of a stylus that only happens in very specific devices, for example. So I guess for Flutter, for me, the biggest quality in philosophy that they have is to support, to provide a great experience regardless what's your target. If you're targeting desktop, if you're targeting Windows UWP, for God's sake. So yeah, that's something that we also should consider when thinking our apps for desktop, or if you're also supporting something mobile, I would also think about providing a great experience for mobile and also provide a great experience for desktop with what is expected for desktop apps. Okay, and of course, large viewports also affects performance. And this goes for this. This is our app scrolling on a 4K screen. It's really funny. It was really funny to see this running for the first time. I almost cried. Yeah, so since we're talking about scrolling, we're gonna just go straight ahead to the next challenge, which is scrolling on desktop can be really trickier than it can be on mobile. I'm saying it has the potential to screw your mind while developing it. For example, rows. I'm going to use our experience here. So, as I said, each table can have hundreds of columns and thousands of rows. This can result in millions of cells. Okay, and it's possible to have multiple tables for each vertical scroll context. Okay, And the cherry on top of everything is multi-directional scroll. Can have vertical, horizontal, and diagonal scroll. And with millions of cells, we cannot render everything all the time. So, we would have to create a mechanism to listen for the scrolls vertically and horizontally, and build widgets under demand. And so we did this with a somewhat known term for among Flutter developers, which is sliver. So basically, each table becomes a sliver in the vertical scroll context, which is basically this representation. So the sliver protocol, it works on a one-dimensional way, and we put one sliver on top of the other. And there we go, we have composed the page. And for the horizontal scroll, each sliver also contains a horizontal scroll view nested inside of it. And then we have the horizontal and diagonal scroll and stuff like that. So this is a little example. So what the hell is a sliver? You asked me, and I answer you, I have no idea, but I read the code a little bit, and the code inside Flutter, because there's not many resources around that. And I still have not complete understanding, but I'll try to explain a little bit. Okay, but to explain a little bit of slivers, I'm going to explain another very important concept of Flutter, which is the cornerstone of the Flutter composition system. I don't know the name, a fancy name for that, composition system or stuff like that, widget system, whatever, which is the render object widgets. So most of us uses most of the time stateless and stateful widgets, but one thing that those widgets don't do is actually puts things, writing things in the screen. So you always gonna use a center or a text or an image, made a gesture detector there. And the stateless and stateful widgets, they don't do much by themselves, rather than just store information in the state and stuff like that, and fetch information from context. And it's basically stateful and stateful widgets, stateful and stateless widgets are basically recipes of how to do things, right? And these render object widgets are the widgets that actually put things in the screen. So they are responsible for painting things on the screen, layouting things on the screen, so layouting children, and also receiving hit text, which is clicks and mouse hover and stuff like that. So for example, a center is a widget that just does layout. They lay out the children in the center, and that's basically, they don't paint anything. Or for another example, an image just paints things in the screen. They don't quite do layout themselves besides layouts for the image itself. And also, for example, a listener or a gesture detector are widgets that just receives hit texts. So yeah, these are some examples. And there are widgets that does multiple things. For example, the selectable text. For example, they also receive rich text and also paint in the screen. Okay, but as an example, I would say we have the widgets tree, where you compose things. So among them, you can have stateless widgets, stateful widgets, and the widgets that paint stuff in the screen, they each create a render object, okay? And this is a parallel tree that's created by the widget tree, but they live longer. So what this means, widgets, they live during a build cycle. Every time the app rebuilds, the widgets will all be destroyed. That's why, for example, state is a class separated from the stateful widget, because the state will survive a build cycle, but the widget itself will die. So yeah, that's it. Widgets are more like recipes, and the render objects are the actual things that survives and imperatively paints stuff in the screen, receives his tests and stuff like that. And as an analogy, if you are a web developer, the render objects would be the DOM, basically, and the widgets will be the components of your UI library. And okay, so there's a special type of render object called sliver objects that are special for scrolling contexts, and they are the direct children of scrollable widgets. For example, custom scroll view. And yeah, sliver constraints are the things received by the render object to the render object to perform its operations, for example, layout or painting. And as a result of layout, the sliver render object emits to the scrolling context would be the view part, if I'm not mistaken, an object called sliver geometry that contains a bunch of information that can communicate to the scroll view enough information to put one sliver after the other. And yeah, and sliver is a very flexible and capable protocol, but it only handles one-dimensional scroll, and they have a natural disposition to virtualize the content. What is virtualize the content? Is to not build widgets that are not inside the viewport. So once you scroll out, these widgets can be disposed if you don't have a tweak called keep alive. But anyway, okay, so we have this amazing virtualization mechanism, but it only works on one axis. So we had to combine these two scroll views, the vertical one and the horizontal one, to create the diagonal scroll. And inside all of those, we can use the sliver constraints, which has enough information to tell the widgets inside these two scroll views how many pixels have been scrolled or where in the spreadsheet the viewport is right now. So as a result of that, we have enough information to decide which cells transform into widgets. And once you scroll and you change the viewport, change the position, we have a mechanism in the elements tree, which is the third one in between the render object and the widget tree, to basically decide which cells to kill and which cell widgets to kill and which cell widgets to build in every scroll. And yeah, this is basically a visual representation of the diff algorithm that we have between two positions of the viewport. And the result is 30 frames per second on a 4K screen. But it's important to say this on release. On debug mode, it's not 30 frames per second. It's nowhere near that on first for 4K screens, but it does the job on release so far right now. And let's see how it goes once we start to put in more content and more complexity in the widget. And okay, this brings us to another challenge, which is more intrinsic to going desktop rather than just Flutter desktop, which is you are not living in a touch screen first world anymore. It's a keyboard and mouse. And regarding mouse, there's a lot of difference between a finger and a mouse cursor in terms of how you think your UI. A finger is imprecise, so buttons have to be bigger spaces, and there's the possibility of multi-touch. On the mouse, you don't have multi-touch. And also there's a possibility, the scrolls work differently on touchscreen. Drag, you scroll. On desktop, a drag can mean something else. For example, in a spreadsheet where a drag select cells doesn't scroll. So in the beginning, we had to override a little bit of the behavior on Flutter, but that was fixed on last year on Flutter desktop. And dragging doesn't scroll anymore on desktop unless you manually override that. And okay, there is something new on Flutter desktop that probably you have to think a lot. is about the hover state that's now visible. So you'll probably end up using mousy area a lot because of that. So for example, here on our app, we have hovers everywhere, and it was pretty fun coming from a Flutter mobile experience to think about hover in Flutter. It was really great to see. And this is an example of how the dragging on our spreadsheet doesn't scroll, they just select stuff. And okay, regarding keyboard, okay, there is a big difference right now on having a keyboard always there for your app to receive inputs from. And mobile apps and touch-first apps, only visual things can trigger actions. But on desktop apps, you may have a shortcut that triggers some action from some widget that's not even the screen at that moment. So you have to think about that, and have to think about focus. You're probably going to end up using focus nodes a lot, and depending a lot on that, because if a widget's focused, this widget will be the target for a keyboard action or a shortcut. And there's this, I think this is probably my favorite API in Flutter, which is the shortcuts /intents /actions that can allow you to map user keyboard combinations to trigger intents, and these intents will trigger actions. An example of that is this little button, the bold one, where clicking on the button, you'll trigger an intent. And also pressing Command B or Control B if you're on Windows, you also trigger the same intent. And this widget, of course, this one is always visible for some reason, but it doesn't need to be like that. The widget receiving the focus from the user input is always ready to receive that input once you are in the editor view. And okay, this one is about Material and Cupertino. Okay, this is personally my biggest frustration with Flutter Desktop, but it's nothing that you cannot work around. So Material and Cupertino are not entirely made for desktop. Things like these two things right here. Of course, some people can find usages for them on desktop. I'm sure of that. But in most cases that these would be no-brainers on mobile, we don't have actual substitutes for that on Flutter, at least inside the framework itself. There's always third-party libraries, and this is the thing that you will see on desktop, that user interface design systems mostly depend on third parties. For example, macOS UI, which is amazing, and there's also the Fluent one that was presented on the release of Flutter Windows. But there's a difference between having something in the framework and having it as a third party, which for some people may be a deal breaker. For most cases, especially macOS UI will not be, because it's really well maintained and it's really great. But for most Flutter developers, going and using things from Material is always the first line of thought, maybe. And this probably won't be great in some very specific aspects. And actually, we had to override and rewrite a little bit of some widgets from Material. I think the biggest work there was with the nested submenus. The menus on Material are not that flexible, are very, very difficult to change some aspects, like nested menus, where we have on our app in some places. And our date picker, we had to rewrite a little bit because the range date picker, especially on Flutter, on material, fills the whole screen basically. And we didn't want that. We ended up doing inside a model that quite didn't work, so we had to rewrite from scratch the date picker because it was not very flexible for changes. It shouldn't be because it's made for mobile. So that's something to think about. And also we had to change some aspects of models, and especially buttons. Also, it was a big rewrite. And yeah, other challenges, we have a very, I'm not gonna enter the details of those because we don't have 1 hour here to talk about, just 30 minutes. So we can talk this about this after the event if you're up to, but yeah, if you are from home, you will not see that discussion. So your problem, you should have come here. Okay, so other challenges, text editing, not only text editing is related to text editing, but is our formula composer, Canastro, made, or can I call you Ricardo Jorge? Yeah, Ricardo Jorge made a thread on Twitter about that, and it was, I guess, it only seconds the grid in terms of complexity. I guess it surpasses a little bit in terms of complexity of editing our formulas. And okay, there's also the clipboard, which was recently tackled by Bottom Edge, which is clipboard on Flutter on mobile devices are mostly just text, copy text and stuff like that. But on desktop, you can also copy chunks of HTML and transfer rich information between different applications. Actually, you can put anything on any format on the clipboard, and if the receiver can reach that format, it will be transferred between applications. So both on macOS and Windows, they are slightly different, but it's pretty much the same thing. You have formats, and you can copy and transfer, and Flutter is not ready for that, so we had to build our own plugin for that. And we also had to do some tweaks, both on macOS and Windows, to override the pre-built window Chrome. The window Chrome is that interface that's defined by the operating system, basically. So the top bar, the close, minimize, maximize buttons, and stuff like that, we had to rethink that thing, and also add capability for Flutter widgets to change a window position once it's dragged, or double click on that widget and we'll maximize the window. So this kind of behavior we had to implement on our own. Custom plugin, talking about our own custom plugins, we're gonna keep sharing knowledge through our blog. And also, most importantly, we will open source most of our stuff. Yeah, it was really hard to not say the other word with S right now. To open source our stuff, because yeah, we have lots of things done and we're just preparing them to publish. The first one will be the spreadsheet table engine, which is basically the whole sliver, grid, diagonal scroll, yada, 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 forgot, that we're gonna publish. And there's a finite state machine that Canastro created for the formula editing system. There is the desktop clipboard plugin, the native window that removes the window Chrome, and also a small package for Sparkline chart widgets, among others that may come. So stay tuned. And for real now, this is the end. Any questions? Do we have time for questions? No? How can I see that? Yes, platform-specific challenges.
Yeah, please read the question.
Okay, did you face platform-specific challenges, or did you have 100% code-based reuse? Oh, we had platform-specific challenges. We still have some. For example, scrolling horizontally with Shift, we had to do a workaround on Windows because it doesn't work. on Windows with Shift. On macOS, it's fine. You press Shift and you scroll with the window with the mouse wheel. It scrolls horizontally beautifully. But Flutter doesn't map that for Windows. So what you have to do is to invert the axis of the pointer signal on Windows specifically. And in terms of platform-specific code, there's this thing that I just said about plugins that we had to write. So everything was written apart for Windows and apart for macOS. So the clipboard, for example, so we wrote the Windows part and the macOS part with Swift. And Windows was on Windows 32, pure C++. Any questions from people that came here? No? Okay, looks like you put a lot of work into it and managed to get an amazing result. How long did the development of this project take in the development phase? Woo, this is still work in progress, man. Amazing results. We still had to see that in the future. We had to reach parity with the web app. That's still in development. But we started March last year, right after Flutter Engage. I guess the same day we decided to go Flutter. And we released the first beta version of the app on late December. And then was the Windows version on starting of February. So this is basically our timeline. And here we are right now, 1 year later. That's gonna be fun. One more question. Any advice for people who want to get started with desktop development with Flutter? Yes, there was this lots of things that I just said that keep in mind. UI is not gonna be as trivial as it is with Flutter when you have lots of stuff on material to use. So you're gonna have to go deep a little bit. This is a tip I give for anybody that worked with Flutter for more than 2 or 3 years. Go further than stateless and stateful widgets. Stop fighting about state management. That sucks. I can't hear about state management anymore. Go learn how a render object works. Go learn how a center works, for example, or alignment. And go try to figure out how the gesture arena works, how a raw gesture detector works. And I would say, the things that are under the surface for the Flutter engineers to work on. So that I would say has proven to be essential to build the Rose app. And if we didn't know that, if we didn't go to the source code of the framework, we wouldn't have built our text editing, our formula component system, and the grid. So this is the tip I do. Go further, go deeper on the framework. And one more, and that's it. Okay. How is the support for native plugins on desktop? Okay. On macOS, most plugins reuse share codes between the iOS and the macOS implementations. Some of them, because you can build plugins with Swift. And in my experience, it was, I'm not a macOS developer. I didn't have experience with macOS before building this app, but to do everything that was needed, it was pretty okay. In terms of which plugins exist out there, I couldn't find, I don't remember the last time I was trying to use a plugin that didn't had support for either macOS or Windows. So I guess the ecosystem is already well developed, at least the most popular plugins out there that I had to use. And in terms of composing plugins for Windows, that is a little bit trickier because it's Windows 32 and the plugin, the API is not that modern. So it's gonna be a little bit strange for most people. So you're gonna have to care about allocating memory and stuff like that. But there is an amazing package called Windows 32 that allows you to write Windows plugins with Dart using the FFI, which is amazing. Our Windows Chrome thingy, our Windows Chrome plugin, most part of the Windows implementation is entirely made with only Dart because of Windows 32. So I recommend you to check on that because it's amazing. And for Linux, I don't have any experience with Flutter Linux. Sorry for that. But some people say, some folks I know say that it's less harder than Windows because the Windows 32 API it's quite strange sometimes. And that's it. You're good.
Professor?
Oh, yeah.
What is the technology for backend?
Sorry?
The backend, what is the technology?
Oh, sorry. I couldn't understand.
The backend technology. The backend
Oh, the
technology.
backend technology. Oh, that's Kotlin. We have an entire. We use the same backends that the web app uses, and it's GraphQL under WebSockets, basically. And there is an entire microsystem ecosystem that interacts with each other, but they are all basically in Kotlin and some on Java, and that's it. And that's it. Thank you. Okay.
Okay, so we will just have a break of 10 minutes and then we will come back and jump directly to the Erick Zanardo talk, and he will talk about the power of Flutter to create games. So see you in 10. Stay there. For those in person, we have a coffee break that we
Hello. Let me just turn off the music. Stop. Hey, welcome back. Welcome back to the second part of our meetup. This meetup is, as you've seen, is part online, part in person. They are having some sweets right now, and part online. So, and without any further ado, I want to introduce our next speaker, Erick. Erick, jump in.
Hello.
Hello, Erick. So I will leave the introductions with you. The floor is yours. Okay. And hope you have a nice talk. Any questions, feel free to write in the YouTube chat. We are paying attention to the chat, and we'll ask at the end all the questions to Erick. Erick, the stage is yours. Enjoy.
Awesome. Thank you. So first of all, thanks so much for the invitation. I follow the Flutter Portugal meetup for some time. It's such a great honor to be able to share some content here. So first of all, who am I? My name is Erick Zanardo. I am a Brazilian, live in Brazil. I'm a software engineer working with Flutter at Very Good Ventures. And some people may know me from the Flame team. I'm a maintainer there, also part of the Blue Fire team, which has some other projects like other players, and basically some cool open source stuff that I do with this amazing team. So today I'm gonna talk a little bit about how we can use Flutter to create a game. Why use Flutter? That's an awesome question to be answered. And I'm going to show how to get started and things like that. So first of all, I'm going to show a little bit what is a game. How does a game is different for a normal app? So let's go through that before we jump into Flutter itself. All right, so games are software, are applications just like others, but they kind of focus on different things. So one of the things that it focuses a lot is interaction. So a game that doesn't have interaction is not really a game. Like if you can play, what is the point of it being a game? So player actions, any actions like the controlling a character, jumping, aiming on the screen, things like that. Screen gestures is just a different way of interaction, but specific for mobile game, where you have to use touch screens and things like that. And more common on desktop, computers, and so mouse and keyboard, and as many other types of inputs that exist out there, like gamepads, like those driving steering wheels for racing games, any kind of inputs really. Games are also about multimedia. So of course they are awesome games that don't have many graphics, many sounds, but they're always a kind of a medium to show the game information. So graphics, so display animations, displaying cutscenes, things like that. Audio is a great deal of games. So many people will remember games just by hearing their songs. So that's quite a big deal on games. And of course text, so you have to show your players some information, how to play, and etc. Games are also about performance. Of course, any software, any application needs to value performance, but I think this is a very critical point on games, because nobody wants to have a game lagging, to see frame drops. Basically, it's like you can use an app that isn't that great, but it's practically impossible to play a game with a lot of lags and a lot of frame drops. So this is a very big deal on games. And what is the major difference between what we're going to call regular apps and games? The major difference is how from technical point, how the UI behaves, how the renderization process works. So when you're talking about a regular app, usually most of the updates on the screen are triggered by an user input or an event. So like a user gesture when they are scrolling, when they select an item on a list, or maybe a background event, like a push notification comes and we show something to the user. So this is what we usually call passive UI updates. So the updates happen once something happens and trigger that. On a game, this is most of the time not true. So on the game, there are many things happening, even if there aren't any inputs from the player. So I inserted a small GIF there from one of the early games that we did in Flutter. So you'll see that even though the player is not touching the screen, it's not jumping, it's not doing any action, we have animations going, you have enemies shooting bullets at the player, and so a lot of action is going on, even if there aren't any input from the user. So that's what we call active UI update. So basically, the application, the software is always rendering itself no matter what is happening. It's all updated and it stays on that loop forever. And this is what we call game loop. Game loop is one of the most basic concepts of game development. So it is, like the name says, it is a loop. So it stays like, if you're going to do that in code, a very basic code, it would be like a while true that runs forever. And it has those steps. So basically, it receives input. This input can happen on any part of the life cycle of the app, of the game. And then we update the logic for a game and render the snapshot of the state with our updated logic. And this goes and goes forever. Update, render, and this stays looping until the game has stopped running. And why Flutter for that? So Flutter is perfect for game development because it gives us direct access to the graphical context to the platform. On Flutter, in our case with Flutter, that access is provided by Skia and the Canvas class. So with it, we can like draw shapes, we can draw images, we can draw paths, all the primitive functions that we need to draw anything is provided by us through that. It has a high rendering performance. So Flutter itself already works kind of like a game engine, under the hood. So it has its render loop, it's always rendering. So it already has high performance in mind from its core. So that's something that, not that we don't have to care, but it takes care of a great deal of the problem for us. So we can try to focus on more high stuff. It is a mature ecosystem, so there are many use cases. A lot of clients are using that. We have plenty of featured apps using that. Pub.dev has a lot of packages that can provide us a lot of features and plugins and so on. So it's definitely something that we can trust to help us grow our game. And it's multi-platform. So nowadays we have like a lot of platforms to add support. So some people will want to play our game on iOS, some on Android, on desktop. So this, if you want your game to be accessible by the most people possible, Flutter got us covered because it supports all the major platforms. And how we created these game mechanisms inside Flutter. So here, just to mention that we use the scheduler binary to schedule our update methods, and we use a render box to render the game. So this, I'm not going too deep in that because this can take a while, but just to mention what are the means, that the technical means that we use to create our rendering stuff. Right, so, okay, I understand now what is a game, and I want to create my first game in Flutter. So how can I start? First, we need to understand what do you want to build. So, of course, this is just a simplification of things, but kind of there are two kinds of games out there. A group that we will call app-like games, which are those more like turn-based games or apps, games that really looks like app. Remember that I talked before that apps, they have passive UIs update. So they are games that they only update their screen once there is interaction. That's why we use app-like games terms for that. I don't know if that's the best term, but so far is the better that we can use for those types of games. Or we can try to develop a game which I like to call action-packed games, which are the group of games that better describe that GIF that I showed on a previous slide, where there are a lot of things happening, animations, even when the player is not interacting directly with the game. So let's say we want to build an app-like games. Flutter got you covered on that because it already has a vast methods for you to manage your game state. It has a lot of widgets that will enable you to build a variety of layouts. So imagine you want to build that word game. It's basically just like, I can imagine like a container with colors in a grid where you can click and tap and things like that. So you totally can build a game just with Flutter widgets, and I'm pretty sure it will perform well because Flutter has a lot of render optimizations and performance optimizations on that. And not to mention that it has like a very well provided tools for handle gestures, so you can go nuts doing drags and moving things around. And it has hundreds of patches to add all the support that you want for all the features that we eventually want to add to your game. But if you want to build an action-packed game, then you better try to use, it's better if you go with a game engine. So a game engine is, to simplify a lot, is like just a collection of tools that will help you build your games. And those tools may include like graphical tools, like for example, drawing SVGs, drawing different types of shapes, trying animations, frame-based animations. I'm going to show a little bit more in depth what is a frame-based animations. It helps you handling physics. So I think everybody play Angry Birds, so that's a very good example of a game with physics-based mechanics. So, throw the bird, things falls and have gravity. So usually game engines provide you tools to build that, so you don't have to write that from the scratch. It provides you tools for input. So even though Flutter already provides you a vast API for handling input, there are a lot of kinds of input that are specific for games that you may only find on game engines. So game engines will help you with that. And it will provide a particle system, component system, which is just like a way for you to build your game. Just like Flutter has widgets, a game engine may have its own system. So I'm going to show a little bit about Flame, which is a game engine developed on top of Flutter. So if you ever wondered why Flame is called like Flame, it's because it's Flutter plus game makes Flame. It's a fun fact for you. And it's an open source project when we say that it's a minimalist 2D and modular game engine. It's important to emphasize on that 2D. Right now, Flame only supports 2D games because basically Flutter does not allow us to do 3D yet, at least not in a way that it will be performatic, it will be stable. There are many experiments with 3D, but they are not stable yet for us to say, hey, we support 3D. So right now, Flame is focused only on 2D. That may change in the future. And here's the URL for the GitHub project if you want to check. So Flame is modular. So what does this mean? This means that it provides you a lot of feature sets, a lot of tools, and you can choose one or another. You can use all of them. You can use it, for example, I'm going to use Flame just for its particle system. You can, so that's the idea of being modular. It provides you a lot of features. Some of those features are opinionated, like the component system. but you are not you are not required to use everything. You can use only the pieces that you want. So here is an overall of its features. So on the game loop, we have the component system that we call Flame Component System, or FCS for short, which is our opinionated way of how you can organize your components. So like a component can be like a player, a component can be the enemy, can be the shot that your player does. So everything in your game can be a component. We also provide an alternative to the Flame component system, which is called Oxygen. Oxygen is an implementation of ECS, which, if I remember correctly, stands for Entity Component System, and it's a pattern that is very common on game development. So we also offer an alternative to our own component system if you want to try different things. We provide some audio features, which is under the hood provided by the package Audio Players, which is also maintained by us at Bluefire. Under the graphic category, we fully give the user access to the canvas. We have some helpers to help you draw texts and text box inside the canvas. Sprites and sprite sheets, which I'm going to talk a little bit more on the next slides. Isometric maps, which is those maps that they have this cool different angle. SVGs, particle system, parallax, that cool effect, splash screen, and so on and so on. We also provide some good integrations like Tile. Tile is a very famous tool on game development, a very old tool too, where you can create maps. So like you have a tile set, which is basically a palette for creating maps, and you can create maps on that tool, which is specific for that, and then it exports a file. You can import that on Flame and use it on your game. First2D, which is our part of Box2D. Box2D is a physics engine that is also very famous on the game development industry. It has ports for many languages. There is a Box2D Dart port, but we kind of work on top of the Dart port to make it a little bit more Darty, because most of parts of Box2D, they resemble a lot of techniques used on C, on C++. So we kind of created our own branch of Box2D, which we called First2D, to provide a better, more Flutter, more Dart experience for the developers. Fire Atlas is an editor where you can create animations, and Bonfire is an awesome framework for you to create RPG-like games. It kind of resembles RPG Maker if you ever use that tool. And this is not maintained for us, but it's maintained by a very valuable member of our community, so definitely worth checking out. Cool, so let's see some code. Let's see how to use some of those features that I mentioned right now. So this is one of the most basic ways of rendering something in Flame, which is rendering a sprite. And sprite is just a name that we use for rendering images on your game. So here we have a Flame sprite, and we just load that at your component. And remember that I mentioned that we have this component system, and we pass the sprite, we pass on a random position, actually not random, this is in the middle of the screen. We can settle its anchor, so how it will be rendered. If you're going to be, its center will be, if it's 0, 0 will be on center, on the top, pretty much like the align class from Flutter works. And its size, which is just like, hey, render this the double of the original size of the image. Then a more complex graphic. So this is a frame-based animation, which is basically an animation that is created by multiple images, and each image is one frame for that animation. And this usually is a single animation. It will form a sprite sheet. So on the single file, we will have all the frames, and Flame provides this helper for you to load. So basically you just say, hey, this is a sequence animation. I have 4 frames. Each frame has 48 pixels in size, and I want 0.15 seconds between each frame. And Flame will take care to create the animation loop for you. This is a more complex component. I hope you can see the text. I try to make it the less code possible. But this is for how you would implement a player component, for example. So Flame provides for you a lot of helpers for input, like I mentioned before. So on this example, note how we have declared our class, and we add the mixing keyboard handler. This will give this component access to any keyboard input. So on our key event, we basically just identify what type of keys this is, if it's a key down, if it's going left or right. On my example, I use the A key to make the player go left. And if you identify that it's a A key that was pressed, we just move the direction of the user. So next we have to implement our update method of the player. So remember that it is a game loop. So it is an infinite loop that's running. So the update is called every rendering before every rendering of the game. So here we have always to think on the fourth dimension on time base. So basically we just have to calculate our new position by applying a direction, our speed, and our delta time. So let's say, for example, here our speed is 100 pixels per second. So by multiplying that by delta time, we know how many pixels the player needs to move on this particular frame. And the rest we just apply the position to the new position to the position of the component. This is an overall of all the components that Flame provides, and I'm not going into details of all of them, but just for you to have an idea that we have like sprite components, we have parallax components, all kind of components that you can use to compose your games. And also that Flame favors composability. So you can have your components to have components. So with that, you can create like, imagine a player that has gear, that has weapons, and you want to, you can add other components to that player component, so it will create like a composite component. It is basically this. So following that previous example, here we have a player component, and inside it we can add gear components. And by this gear component has a type, which can be an NO or whatever you want to code. And by that you can compose. So your player now can be a composition of many components, which will form this cool effect of the little guy equipping, unequipping, different types of gears. And now this is one of the coolest things that I think that is the selling point of Flame, is that you can use Flame and widgets seamless. So by the end of the day, a Flame game is nothing more than a widget. So you can compose your application using a Flame game and whatever widget you want in a super easy way. So this gives us the opportunity of having a game engine that has an awesome UI library behind, which is something that I never saw in the game development industry. So it is always a pain to develop UI in games. So Flame, you don't have that problem because you have Flutter behind it. So here on this example, you see how the transition goes between one screen to another. You see this hero animation going. It's super easy to do in Flame. So here just showing, just putting some technical terms what I showed on the previous GIF. So basically we have a title page, then we have a game page, and we just use the navigator to go from a page to another. So this is kind of to show how Flame is just a widget, and a great part of your game will still use your Flutter knowledge. So if you know Flutter, you already have a lot of advantages when you try to build your game with Flame. Again, so just demonstration how we use here animation scene from one page to another to create that cool effect. Here, just putting a more visual way, what is Flutter, what is Flame. So on the left, we have our Flame game. On the right, we have Flutter widgets to build this even inventory and I don't know, maybe character status panel. And also, you can use block or any other state management to create a communication between that. This helps a lot you when you want to like create a communications between your Flame game and your Flutter widgets. You can even use a block to manage a part of your game. So on this example, we use an inventory block to manage the blocks of the inventories, the items of the player. So this helps us test, this helps us communicate between the game and the UI. So this is an awesome addition about using Flame and Flutter to develop games. And how this is done? So to make your component, a Flame component listen to block state change, you just have to use the block component mixing, pass the block and the state, and now your component will hear for any state change. And then you can do all the logic that you want. On this example, just for simplicity, you just remove all the year that the player had and add the new ones. So it will present the player with the current selected gears. And another awesome thing about developing games with Flame and Flutter are tests. This is also something that we don't usually see on game development tests, but by using Flame and using Flutter, you have a lot of tools to do that. I'm going to show you a little bit. One tool that we offer to developers are the Flame test package, which is just a bunch of helpers built on top of the Flutter test framework that helps you test some specific things for your game. So on this example, you just have a test that just is not a very complex test. It's just testing if the component is loaded correctly with the parameters that we expect to. So just create a player, we add it to our game, and we assert with the size, the anchor, the animations, have all the correct values. And this is another example of a more complex test. So basically, we create a player, we give it a direction. So vector 1, 0, we are saying that the player is going on the right because 1 is right, minus 1 is left. Yeah, that's right. So it's going to the right. We add the player to the game. We call the update phase of the game for 100 milliseconds. So Flame always works with seconds. So 0.1 here means 100 milliseconds. And we expect that the position is as it's supposed to be. So the player has 100 pixels per second speed internally. So if x is equals 10, that means that our update logic is doing, our movement logic is correct. Another awesome stuff is we can use golden tests for testing games. So when you're developing an action-packed game, there are many things moving. There are a lot of things change, animations, background. So some stuff is very hard to test. So golden test plays a game changer, no pun intended, but anyhow, it's a game changer for testing games because like you can just move your character a little bit, take a snapshot, move something more, take another snapshot. So it gives an easy way to create a test for a complex thing that is testing a game that has a lot of moving parts, a lot of animations going at the same time. So here, just as one example, we just do the setup of our game, we add the component that we want to generate the snapshot, and then we just use the same API that we would use for doing a golden test with Flutter. And this is the generated snapshot for the golden. And there's much more to discover about Flame. This is just like a few things, the most important things that I would like to bring to you. We have a Discord server, which have a thriving community with a lot of people helping, answering questions, sharing their content. We are also always paying attention to Stack Overflow. So if you have a question and want to use Stack Overflow to ask a question about Flame, you can just use the Flame tag, and we will try to answer it as fast as we can. Have our site, on which you will find all the relevant materials, like tutorials, like documentation, examples. All these links are also there. And of course, the GitHub repository. And that's it. I hope you all enjoyed the content, and I'm open to any questions.
Hello, hello again. Here we are. So let me just mute the background here. We are say hello to the online guys. Hello, physical. Yeah, they are the strongest here. That they are still here online. So we do have a question from the audience that I'm going to read you. That is Flame a real alternative for Unreal Engine or Unity? Can you talk about that?
Sure. So it depends. Do you want to do 3D? If so, then no, Flame is an alternative to neither of those because we don't support 3D. But if you want to do 2D games, then I think it's safe to say that yes, it will be different than use Unreal or Unity. Like, we don't provide any UI IDs like both of those engines provides. So some stuff you will have to think a little bit different. But yes, if we're doing 2D games, we have a lot of use cases already of games released that were kind of successful. So yeah, I do believe so. The only thing is that we don't support, at least not well, all platforms. So like Unity supports Xbox, supports PlayStation, supports all these consoles. Unfortunately, we don't. So if you want to do a 2D games on the same platforms that Flutter supports, then yeah, I believe it is an alternative.
Okay, now you can hear me. We just have a question from Rodrigo. Is this the game repository? I think he was mentioning this previous slides.
This is the Flame Engine repository.
And what he can find there?
All the source code of the Flame Engine, our bridges patches like the Flame Audio, the support for Hive, and so on. All the relevant source code of Flame is there.
And now a question while the audience is still doesn't have any question. If I wanted to learn more about Flame, where should I go? And if you have any resources available or workshops?
Mm-hmm. We have a couple of tutorials on our site. So flameengine.org is, I think there you'll find all the links to tutorials, to documentations. Also, I would say that our Discord is a great place to learn. So people always help each other there. So that's definitely a place you would stop by to ask questions and so on.
And can you give us a sneak peek of what should we expect from Flame?
Right now we have done a great deal of work for release the V1, which we did on the beginning of this year. And right now we are like going through our APIs, seeing if there anything that's not that great and improve and add some small bit of features there. So we don't have a solid roadmap still because we are on this phase where we are looking, checking things to make sure. One thing that we definitely want to improve, that we are working for, that is improve the desktop support, because this is kind of becoming more and more a thing in Flutter, like Renan just showed on his previous presentation. So right now, Flame already supports desktop because Flutter does support that, but there's definitely things that we could improve on that. So this is definitely something that we are aiming for on the near medium future.
Yeah, I was asking here if they had any questions, but seems not. But we have time, and we have one more question. And guess what? From who? Renan.
Yeah, this is Flame Xbox One. This is something that I tried already, some stuff, but the support for Xbox a little bit tricky because as far as I know, as far as my knowledge for Windows development goes, we need to use UWP for that, the Universal Windows Platform, and that is a little bit not stable yet on Flutter. So we have tried sometimes. I know there are some Flutter users that were able to run Flutter on Xbox, but since we have this instability on support of this, we don't have much news for that. But it's definitely something that we would love to add support to.
Yep. So doesn't seem we have more questions. I just have to say thank you so much, Eric, for giving your time to give this talk. And we had many people interested in hearing more from Flame. So probably I will talk with you again to give a talk. Okay.
Awesome.
Thank
Thanks
you.
so much.
Cheers and see you soon. Bye bye. So here I am alone. I switched places just to talk a bit with you. Thank you so much, you personally, for staying so long, and thank you guys that are seeing me on the live. Well, you lost the opportunity to being present. I hope next time you'll be able to attend, and see you next time. Bye.